All right, let's go ahead and get started. Good morning, everyone.
Morning.
How's everyone this morning? This beautiful, beautiful central New York day, right? This is what we love about the wintertime days like today. My name is Marv Meisner. My role here at SUNYIT is Associate Director of Professional Development, and I do a lot of stuff, but one of the things I do is coordinate this new program that we're calling SUNY Best, and we'll talk to you in a couple of minutes about what that really means and what that's really about. Again, I'd like to welcome you all here this morning. And cloud computing for small companies is the focus of today. And you can see there's a lot of acronyms here. We're calling this a CGAM, SUNY Best, SBDC, SUNYIT event. What do all those things mean? Well, SUNYIT, we know what that means. We're familiar with that one. SBDC is the Small Business Development Center that's here at SUNYIT, and they are co-sponsoring this program this morning, so I really appreciate that. And we have Dave Mallon, the director of SBDC, is here. It's just everybody, so that's Dave. Okay, so we really appreciate and thank Dave for that help. Now we'll talk a little bit about what this thing called CGAM is. Okay, I thought this would be a nice slide to have this morning, kind of make us, since there's only a month till spring, I thought that would be really nice. We see CGAM as kind of an umbrella over a number of different things. Okay. Well, what is CGAM? What does it stand for? It stands for the Center for Global Advanced Manufacturing. And CGAM is a joint venture between folks down in the Hudson Valley and folks here in the Mohawk Valley. And we've kind of gotten together to form this organization. What is CGAM? This Center for Global Advanced Manufacturing, and this is kind of just the language we have. Interregional, which means there's at least 2 regions, and Mohawk Valley, Hudson Valley. We're also talking to folks in the North Country, and we're talking to folks to the west of us in central New York. So it's gone from 2 regions, and it's going to 3 or 4 regions, and maybe someday will even be statewide. Industry-led. So really the focus is on industry and having a lot of folks from industry give us input on it. Public-private partnership. It is a 501c3 organization, and it's dedicated to enabling manufacturing innovation and engaging academic institutions. Now, having said that, yes, in the name it says manufacturing, but we're going to go broader than that. Like today's topic, this is cloud computing for small companies. So you don't have to be a manufacturer to be interested in that topic. So even though CGAM is very much focused on manufacturing, there'll be many programs that go a little bit broader, a little bit more inclusive of other folks besides just the manufacturing folks. What is this organization, CGAM, going to do? I'm not going to read this to you, so you can just take a look at that. But really what we're trying to do is our focus is on small, medium-sized businesses, high focus on manufacturing folks, and what we're trying to do is to bring manufacturing into our regions, retain the manufacturing we have in our regions, and provide basically services to that end. So that is what CGAM is all about. Okay, so that's the umbrella. CGAM's our umbrella. Then under CGAM, there are a number of things that we're going to be working on. You know, first of all, services. There'll be a bunch of services under CGAM. One of them is going to be a characterization laboratory. We already have one up and running in the Hudson Valley, and we're going to replicate that here in the Mohawk Valley. And a characterization laboratory is basically a laboratory that's filled with equipment, and some fairly expensive equipment that individual companies can't afford to buy. Small companies can't afford to buy this equipment, so they would come and use our characterization lab. And the services would be either free or very low cost. So there's one thing under CGAM that we expect to do. Another thing is conferences. We'll run some conferences. We ran a manufacturing conference back here in September, and we'll probably do that again sometime in the mid-year. They'll do something similar down in the Hudson Valley. Training. We want to be able to, as we get established, We want to be able to do some training for folks, and again, training that people may not be able to do on their own in terms of small companies, and be able to help them with that. And then finally, that brings us to SUNY Best. Okay? What is SUNY Best? SUNY Best is something that started actually at Binghamton University. And they had the idea a couple of years ago that they would start bringing people together to collaborate. So once a month or once every couple of months, they would have people from business, education, government, public, private, lots of different entities represented who would just come together and just network, have a presenter, and it's been very successful. It was very successful down there. It was so successful down there that we decided to replicate it here. So that's what SUNY Best is all about. It's the lectures, meetings, networking that are part of the CGAM organization. Okay? So that's just a little bit about how it's structured, what CGAM is, what SUNY Best is, and then we'll go ahead and move into the program. Our first speaker today is going to be Roger L. Norton, and he is the Dean of the School of Computer Science and Mathematics at Marist College. I'm not going to go through, I'll let you introduce yourself as much as you'd like, or as much detail as you'd like, Roger. Okay. Oh, it's a long presentation, huh? Well, this sounds like an interesting one.
Could I?
Yeah, please.
Go by date modified. That's good.
That's the one? Okay. You want to introduce yourself a little bit, talk about a little bit what you do at Marist also.
Sure. So, welcome everybody. I'm coming out on this slippery day. My car was slipping all over the place this morning. So, as Marv said, I'm the Dean of the School of Computer Science and Mathematics at Marist College. I've been there for 32 years, hard to believe, but I've been there for 32 years. And the School of Computer Science and Mathematics, we have a number of undergraduate programs, graduate programs, but one of the things that we really stress at Marist College in our school is applied research. And applied research to us means having our students work with companies. And our students work, we don't require our students to do internships, but we strongly encourage it. And our students literally work around the country. Our students do work with Cisco, at Facebook, at Apple, at Microsoft. Our students usually get hired at those particular places. And we also, at Marist, in our new building, we have a applied research laboratory. We have literally millions of dollars of the most high-tech equipment available to our students for doing applied research, working with companies. And we have some particular areas of focus. We do things in networking, we do things in enterprise computing, and we also do things in cloud computing. And so it's the cloud computing part that I'm going to talk about right now. That's my diagram that I put together. We applied for funding from New York State to fund a Center of Excellence at Marist College in the area of cloud computing. We received that funding. We received $3 million to create a New York State designated Center of Excellence. It's called the New York State Cloud Computing and Analytics Center. So we received $3 million from the state. We received about $3 million from the federal government. And we have a commitment from IBM for about $11 million a year to fund this particular center. And really what this center is, the purpose of this particular center is the characterization lab. exactly the characterization lab. Where you have a lab in which you have a bunch of equipment available to manufacturers, that's what we're going to do. However, our characterization lab is not a physical location where you go and you utilize equipment. Our characterization lab is giving companies throughout New York State, small, medium-sized enterprises, access to technology, access to services, platforms, and so forth. So that's just sort of the organization. I'm going to get into more detail about that, in a moment. So my talk is going to be on cloud computing, what we're going to be doing at the center, but it's really focused around change. So I'm going to talk a lot about change because cloud computing brings the potential for some major change in the way in which organizations function. And so I have down here these 6 principles of transformation, because this is really going to be transformative. It has the potential to be disruptive in the way in which businesses do business. So start a movement. The movement for us is in this area of cloud computing. Establish clear governance. That's been put together. Have data-driven discussions. Just don't move ahead. Look at facts. Look at information. Look at data to help you decide what you're going to do. Radically simplify processes, and that's extremely important in terms of what it is that we want to do. Invest in transformative innovation. We have lots of investment. Lots of people who invested, in our particular center. Not only the state, federal government, Marist College, companies, and embody creative leadership. So the times they are changing. And I'm going to talk about some changes that have taken place, and a lot of these are really very much directed, related to the area of cloud computing. Apple launched iTunes in 2003, so about 10 years ago. Apple, a computer company. Less than 5 years later, this computer company became the largest retailer of music in the United States. Nobody sells more music than Apple, selling it through the cloud, through iTunes. A computer company went to become the largest retailer of music. How many people buy all their music from iTunes? I think it's the only place I buy it. Netflix launched their mainstream movie streaming service in 2008. That's the streaming service. You could rent the CDs prior to that. Today, they account for almost 30% of internet traffic in the United States homes during peak evening hours. 30% of all traffic going into homes in the evening is coming from Netflix. The streaming, the delivery of movies in a new and disruptive way. 15 years ago, somebody was to ask me to pick who I thought was going to be the winner in terms of movie rentals. Blockbuster was kind of a big name out there. Is there any Blockbuster stores even left? They did not change. Amazon started selling ebooks in 2007. In May 2011, Amazon announced that it was selling more electronic books than print. So more electronic books are currently being sold than paper books. 244. It's a big number. It actually corresponds to years. Encyclopedia Britannica ended its print edition after 244 years. 244 years they were in existence selling those books. When I was in high school, we had our Encyclopedia Britannica. All my research was done on those books. They are out of business. The print edition is out of business after 244 years. Very disruptive, technology. Nowadays, Wikipedia is where all our students go to find their information. So, disruptive innovation, why change now? So, talk a little bit about automation versus disruption. So technology has primarily been used to automate education. So I'm going to talk a little bit, about how it affected education. But to automate education, we went from transparencies to PowerPoint. It was not disruptive in any way. It was just a new way of doing the same thing. Did not disrupt how education was done. Lectures, went to podcasts. We now have lots of lectures actually being done to utilizing podcasts. Automation brings value. It makes things more efficient and productive. But automation itself is not disruptive in nature. It doesn't necessarily lead to innovation, nor does it result in new business models. We really want to talk about those particular types of technologies that are disruptive. Look into the music industry. So iTunes version 0.001. For 50,000 years, this is how music was delivered. People went around to places and they did their performances live. You went to see people. That was it. That was the only way to hear your music for 50,000 years. Then this is disruptive, totally disruptive. So the phonograph, 1870s to 1900, the phonograph created an entirely new business model. It just totally disrupted the way in which music was being delivered. It wasn't just an automation, it was a total disruption. And imagine all the jobs that were probably lost when phonographs became available. Then there was automation following that. The LP, a long playing microgroove record came in 1948. Not disruptive, but a better automation, the ability to put more music on a particular device. And then over the years, things have changed. We had tapes, cassette players, we had portable Walkmans, CDs. Those are all new technologies that allowed us to deliver the same thing, but they weren't disruptive. They didn't in any way sort of change the whole business model. It was just a different way of delivering it. Of course, you always had to make decisions. What thing am I going to buy? I remember when there was VHS and Beta. Which one of those things was going to survive? Disruption, true disruption, creates threats. Tower Records, Border Books, Blockbuster, closed. Those places closed. But the disruption, the delivery of music in a new format, streaming it across the web, in the cloud, was disruptive. It changed the way in which we did things. But disruption hurt these people, because these people, was not prepared for that disruption. But it certainly created great opportunities for other organizations. Netflix doing extremely well. Kindle readers. So look at Amazon. Amazon sold books, but they're not over here on the left-hand side closing. They embraced that particular technology, that new format of delivering things through the cloud. So, a few words about cloud computing. That's what I'm really here to talk about, cloud computing. So, what is cloud computing? Cloud computing is just simply a way for a company of any size to share things. And what types of things can you share? You can share storage, services, software applications, platforms, IT infrastructure. And the nice thing about it is you only pay for those resources that you use. Nowadays, you go to any organization, we're talking about manufacturers, go to manufacturers, they all have their own IT infrastructure to support their own IT applications and services and so forth. And everybody buys a license for whatever software is being utilized. Well, is that really the best model? If you think of the music and movie industry, for years, there was a particular way to watch movies or listen to music. You bought devices, you bought tape recorders, you bought DVD players, CD players. Of course, you had to support all these technologies. You had to make the right decision, and if you made the wrong decision, in terms of CDs, high definition CDs, there was Blu-ray and then there was high DTV. Those were the two kind of high definition formats for CDs that were competing, and you couldn't buy a device that did them both. You had to pick. And I remember going to the store and getting myself a high definition CD player and deciding which one to get. I decided to go with Blu-ray. That happened to be a good decision, but many people went with HDTV. If you went with the high definition, it disappeared. Now, all those people who had bought those devices had to then go off and get rid of those and get new devices. So every home in the world who owned those particular devices could no longer utilize those, except for the old CDs that they had. Anything new coming out, nobody was going to be developing things in that particular format. So, it creates problems if you think of a manufacturing company in terms of doing something similar, in terms of buying particular software or services and so forth, and something becomes no longer supported. They then have to go off and buy something new in order to support the new formats. Well, rather than each of the small enterprises doing that, maybe it would be a better idea for people to share particular devices. So, some real examples in terms of cloud computing. Marist College, we've been doing cloud computing for a long time. We have something at Marist College called the Knowledge Center, which provides through the cloud ZOS images. ZOS is an operating system that runs on a large mainframe system. Those large mainframe systems are very expensive, but there are lots of jobs out there if you have knowledge in that particular area. But not every college or university in the country can go off and buy themselves a Z Enterprise system to support that particular environment. But they want their students to have access to it. So Marist has the Knowledge Center. The Knowledge Center allows any college or university in the country to create accounts for their students, in which their students will then have access to a ZOS environment for them to take a course, any course. And we have, I think there are something like 600 colleges and universities across the country that use that particular cloud environment that we have, including many schools in New York State. RPI teaches a course in ZOS, but they utilize the Knowledge Center at Marist College. Their students literally log into Marist College, Clarkson, Columbia, RIT, Syracuse, New York Institute of Technology. They all utilize that cloud environment. And so, when that particular equipment changes, all those institutions, those 600 institutions across the country, don't have to go off and buy that new equipment. All they simply have to do is have Marist go and buy that new equipment, and then they just simply utilize it through the cloud. I just put this up here. I'm not really going to talk much about analytics, but our center is actually the Cloud Computing and Analytics Center. So those are sort of the two things that our Center of Excellence is focusing on. And so I'm just going to tell you a little bit about analytics. Analytics is also known as business intelligence. And what analytics allows companies to do is to look at large amounts of data and extract insights from that particular data, and utilizing those insights help their businesses to make good decisions. And some good examples of some analytics that's being done out there. The IBM Watson system, the system that beat all the major players on Jeopardy, that utilizes a major analytics system built inside, utilizing unstructured data. It's not looking inside a database. It actually is. It actually input encyclopedias, medical books, periodicals in an unstructured format, and analyze that to actually make decisions. The Open Academic Analytic Initiative at Marist College that was funded by the Bill and Melinda Gates Foundation. Lots of colleges and universities across the country are now doing education online. Students are taking courses online. Do students take courses online here at SUNYIT? What system do you use? Do you use
Angel.
Sakai? What is it?
Angel.
Angel? Okay. Which was bought by Blackboard.
Right.
Well, students, logging in every day, they're looking at information, they're participating in discussion threads. One of the researchers at Marist College looked at data over a number of years from a number of universities across the country, including some very large universities and also some universities in which students tend to be at risk. And they came up with a predictive model looking at the data that was pulled off from a learning management system and could decide, make a prediction in terms of after a couple of weeks, by looking at all that data, all these students, what students were at risk. And it was very good at predicting which students were at risk. And its first iteration, what it simply did is it said, all right, we believe that these students at risk. It allowed the students to go along, and it said, all right, well, these students, yep, they failed. Okay, that's good. So that's not awfully useful to know that somebody is going to fail. What they then did is they utilized that same information, came up with that same group of students who were at risk, and then they actually did some intervention. The students were sent messages, sent emails, saying, you haven't been doing X. You need to be able to do. You need to be doing more in order for you to be able to pass this course. And it became extremely successful. About 75% of the people that would have failed based upon the prediction ended up not failing the course because of the intervention. Another example is, Marist College, we have what's called a sentiment analysis using, Twitter. That particular project, you can pick any subject you want. Pick SUNYIT. You can ask it, tell me, what is the sentiment right now about SUNYIT? It will look at all the tweets that are going on out there. It looks for tweets that have SUNYIT in those particular tweets, and then does an analysis about that tweet, and it ranks that tweet as being 2, 1, 0, -1, -2. 2 meaning it's a very positive tweet, -2 meaning it's a very negative tweet, 0 meaning, well, we really can't tell. And then from that, it can actually give you a real-time graph as to what tweets are going out associated with SUNYIT in terms of positive or negative. I've used this numerous times. We've had presentations on this, and we showed this diagram associated with Marist College. That they did an analysis of Marist College over a particular period of time, and there was this one particular time in which Marist College just went way the heck up. All the tweets were very positive tweets, and we looked at that particular time, and it was the time in which the women's basketball team made it to the NCAAs. So what we saw there in terms of this analysis was something that was was really happening out there. So that's analytics. So back to cloud computing, which is really the rest of my talk. So what is not cloud computing? So this actually comes from somebody else, but I like it, so I borrowed it. The wallet test. Can you buy it with a credit card? You need to be able to purchase this with a credit card. If you have to, fill out invoices, you have to do all sorts of things, then it's not cloud computing. Cloud computing is something that you should be able to gain access to immediately. You should be able to use your credit card. The ATM test. Do you have to talk to a person? You shouldn't have to talk to a person. It should all be automated. You should be able to go to whatever your cloud service is and get whatever it is that you need to get without intervention of a human. The kick test. Do you end up owning something? If you own something, then it's not cloud computing. You do not want to own anything, because if you own it, as soon as that thing becomes obsolete, you then have to worry about selling it. You want somebody else to worry about having to sell it. The supersize me test. Can you get 10 times as much of it whenever you want? Very important. It has to be something that right now, this is all I need, but a little while later, you need a whole lot more. There's a company out there that we work with. The president of the company happens to be a graduate of my program, but it's 1-800-Flowers. So if you think about 1-800-Flowers in terms of their technology infrastructure, anything happened recently in which 1-800-Flowers probably needed more technology infrastructure than they do today? Valentine's Day. Valentine's Day, the traffic at 1-800-Flowers goes 10 times what it normally is. It's just, and so what can 1-800-Flowers do? They do not want disappointed people on Valentine's Day when, husband number X is trying to get something without talking to a person, using his credit card, and getting it, immediately, because they just remembered Valentine's Day that morning. Those people can't be disappointed. And so 1-800-Flowers has to make certain that they have the infrastructure in order to deal with that peak day, because they can have things going wrong. But if they actually built their infrastructure for that peak day, then they would have huge wasted amounts of material across the rest of the year. And we're talking about 10 times as much. They would have to build technology infrastructure 10 times of what they need on a regular day as compared to during Valentine's Day. Then the Roach Motel test. Can you take your app and data somewhere else whenever you want? Very important. You do not want to get connected to a cloud service in which you're going to always be connected to that cloud service. If you cannot take your data and move someplace else, then that's not something that you want to do. So, cloud computing, by the way, cloud computing is it's a new term, and its exact definition nobody knows.
When you say take your data, is not your data on the cloud?
Depends. It depends. There are companies that we work with in which they do not. They want to utilize some of our services, like our analytics tools. They don't want their data on our machines. They want their data on their site, and they want to simply because of privacy type issues. But in many cases, the data can indeed also be stored in the cloud.
Access is the real key.
Well, not only access, but the thing is that, let's say you're utilizing some particular service. Marist College, we have a service related to analytics. We have some of the most sophisticated analytics tools out there available. We make it available through the cloud to anybody that wants to use it. They want to analyze data. They have some data. The fastest way for them to actually be able to utilize our software to analyze their data is for their data to be housed locally on the same system as the analytics tools, just simply in terms of bandwidth type issues. And so in that particular case, their data is actually on our servers, but then they decide that you know, they're no longer interested in utilizing what Marist College is offering. You don't want to be in a situation where we're going to say to them, well, okay, well, you know, goodbye, you know, we have your data, by the way. You can't have that data back. Once it's on our server, it belongs to us. You need to be able to get that data back if you're storing it on the server. And anything that you've done to it over the years that perhaps you might have been utilizing that server, whatever changes have taken place, you need to get that back also. But data can be in both places. Pardon me?
What do you do with all the backups? Do you erase all the backups for the last 5 years?
In terms of
Their data.
in terms of their data,
You have to back it up every night, or every week, or whatever.
we have to back it up. And the thing is, there are two questions associated with you know, getting that data back. One question is related to the security of that, in terms of, you know, maybe it's sensitive data. And if it's sensitive data, there's going to have to be facilities within the cloud to make certain that that data is secure and that only they can actually see that raw data. So there's that security you know, issue associated with it. But in some cases, security is not really an issue. You know, they don't care that we actually see that data. But in either case, whether it's encrypted or it's not encrypted, you want to make certain that that it's your data. No matter where it's being stored, you gain access to that data. So as I said, cloud computing is just a new term. Lots of people define it in different ways. I just defined it in some particular way, but you know, somebody else may disagree with some of the things that I said. But cloud computing is not, you know, it's not really something brand new. Cloud computing has been around for a real long time. It just, you know, been around in, you know, different, you know, names. Grid computing. We were funded by the National Science Foundation. We had a grid computing center at Marist College. You know, grid computing is, you know, a type of, you know, cloud computing in which things are being done across multiple different types of you know, devices. Utility computing, that was a big term utilized by IBM. They always talked about utility computing. And the idea was, you know, utility computing, think of it in terms of utilities, what we normally think of utilities, you know, your power, you know, your water, those types of utilities. You don't think anything about, you know, where the heck does your power come from? Where does it come from? It probably comes from Niagara Falls. I don't know where power here comes from. But you don't have to think about it. It just simply comes to you. You pay your bill, it comes to you. And, you know, utility computing was, you know, and you pay for the amount that you use. Utility computing is that same idea. You know, computing becomes available to you just like a power company. And, you know, current term, cloud computing. And when people talk about cloud computing, they talk about it in terms of 3 different types of cloud computing. And we'll start with this one, because this is really the one I'm talking about mostly. And this is the one that's probably going to be the more important one with respect to the New York State Cloud Computing Center at Marist. That's software as a service. So this is where software, applications, ERP systems, CAD systems become available to people through the cloud. So that's SaaS, software as a service. Then there is IaaS. That's infrastructure as a service. Infrastructure as a service is what 1-800-Flowers needs. 1-800-Flowers doesn't need some software. They need, when Valentine's Day comes around, they need infrastructure. They need more bandwidth, they need more servers, they need more processing capability. Their infrastructure needs to grow to support the processing that they're done. And then there is what's called platform as a service. Platform as a service is you're given a particular platform. You know, for instance, you know, Amazon. You know, Amazon's made some very, very good decisions over the years, but Amazon has a platform as a service. Everybody is accustomed to utilizing Amazon and the ability to purchase things, the ability to sell things, the infrastructure that's needed in order to support the Amazon application. Well, Amazon also sells that platform, so you can, through the cloud, actually purchase that infrastructure. So you pay for as much as you need, and you actually have access to the exact same type of an infrastructure platform that Amazon uses to build their particular company. So platform as a service, software as a service, and infrastructure as a service. So the software delivery model, software as a service, increasingly popular with SMBs. Lots of small, medium-sized enterprises, businesses no longer support their own mail infrastructure. For instance, they're utilizing some cloud-enabled mail system. Everybody used to have their own mail system in-house. That's something that has moved away. No hardware, software to manage. If you're not running your own mail system, you don't have to worry about the software or the hardware to manage that. And as a few years go by, that server becomes outdated, the software becomes more sophisticated. You don't have to worry about purchasing new hardware, purchasing the latest version of the software, and you don't have to have somebody that knows how to do it. Service is also delivered through a browser. Normally that's the way in which you gain access to the server. You just simply open up your browser, you simply then utilize that particular service. So, advantages, pay per use. Use a little, pay a little. Use a lot, pay a lot. Instant scalability. Your company has 3 people, you have 3 mail accounts, all of a sudden it's grown to 100. Instant scalability. You can immediately scale up. You don't have to worry about whether you have the hardware to support it. Security. It's very important. I'm saying security, that's one of the advantages. It's the advantage if the people who implemented it right. It's something that you need to make certain is indeed a component of your cloud service. Reliability. Gmail needs to be up. And if you're utilizing business Gmail accounts, it's going to be up. More likely it's going to be up than if you're running your own mail service in-house. APIs, application program interface. Your software should have the ability for you to gain access to it through application. You can write an application that actually allows you to do something more than what the service itself delivers. You want APIs to be there to give you actually more flexibility. So examples. What are some software as a service that you can get out there? ERP systems. Small organizations probably don't have a very sophisticated ERP system, but as those companies grow, ERP systems become extremely important. Ability to schedule meetings, human resource software out there, office products, CAD products. CAD products is something important to manufacturers, and CAD software is extremely expensive. You're a small manufacturing company, and you're doing a bid, and some particular organization wants all your bids to come in utilizing some particular CAD product. It can cost you thousands of dollars, and you may use it a couple of times a month. Why should everybody buy that CAD software? Why don't you have some central location in which that CAD software is available, and it then is utilized by everybody for the amount of time that they want to use it. When I was giving my presentation to the state, asking them for funding, I actually talked about these particular types of things. And one of the women who was on the council said, well, is that legal in terms of making software? You buy software and make it available to other people? And I said, yes, it's legal. It's what you do, depending upon the software, you purchase the software and you purchase a certain amount of licenses. Say I purchase 100 licenses, but I have 1,000 people out there who want to use it. Well, that's okay as long as at any given instant I only have 100 people utilizing that software. And the woman was a lawyer, and she says, well, the first thing I would do if I was that software company is I'd make that illegal for you to do that. And that took me there. And so then I thought about it. I said, well, that's how America works. Car rentals is exactly that particular type of a model. A company buys.
Libraries illegal too?
Pardon me?
Would she make libraries?
Yeah, the libraries, all these things. I said, well, a car company, they buy 100 cars and they rent those cars out to thousands of people. They're not allowed to, rent out. How many cars did I say buy 1,000? They're not allowed to, rent out 2,000 cars because they only purchase the license for all. They actually physically purchase those particular, vehicles. Should we outlaw, car rentals? So, anyways, hopefully she doesn't get a job in some software company. So, what are some of the commercial services that are, currently, out there? In terms of software as a service, email cloud, a lot of people utilize it. Salesforce is probably one of the biggest cloud successes out there. It's used to manage the Salesforce. So Salesforce, all the information about the things that they're actually selling, their accounts and so forth, are available through the cloud. And as these people travel around the country, they don't have to worry about making certain that their iPad or their notebook computer has all the up-to-date information. They just simply, wherever they are, they access Salesforce. What was this one right here? I can't even read that one. Oh, that's IBM. IBM actually has a number of software as a service applications going on, and of course, as I said, Marist College. We right now probably have about 10 different software services available through the cloud. Okay. Then platform as a service. So platforms are built upon infrastructure, which is expensive. Platform is if you think of what I talked about in terms of the Knowledge Center at Marist College, in which we make ZOS available. ZOS is a platform. It sits on top of infrastructure, a Z computer, but it's a platform. Estimating demand is not a science, and so if your needs go up, you have to have the ability to increase your platform. And platform management is not fun, especially if your main line of business has nothing to do with technology. You don't want to end up having to manage your platform. Some popular services associated with platforms, storage, database, scalability in terms of increasing your platform infrastructure. Advantages, very similar to software as a service. Pay per use, instant scalability, security, reliability, APIs. Some of the platforms as a service that's out there, as I mentioned, Amazon Web Services. They say, wow, we have this cool, platform that we use to build our, our site. Why don't we make that available? Not only do we sell stuff, we also sell our platform. Google Apps is platform. Sakai is a course management system. It's an open source course management system developed by funding from the Mellon Foundation, Marist College, and we're very much involved in that entire process. The chairman of the Sakai Foundation was actually at Marist College, and it's available as a platform through the cloud.
Would Rackspace be a platform service?
Rackspace, yes, that would be. depends upon whether it's the actual physical space in terms of devices in there. It could be either platform or it could be infrastructure as a service. It's one of the two, depending upon what it is that's actually being delivered to you. Then computer infrastructure delivery. So this is infrastructure. So you have access to some infrastructure stack, full operating system access, access to firewalls and routers and load balancing. So this is really sort of a data center available to you, through the cloud. Advantages, same stuff as software as a service. Some examples that are out there, IBM, Amazon, Mosso, Marist. Common factors of all of them. Advantage, lower cost of ownership, reduced infrastructure management responsibility, allowed for unexpected resource loads, faster application rollout. Risk, security. It's always something you have to be worried about. Downtime. You have to make certain that the organization that you're working with is a reliable access. You've got to make certain you have appropriate access, dependency, interoperability. You don't want to end up getting into a situation where you're dependent upon that particular cloud service, whichever one it is. You need to be able to move. Interoperability. So, the New York State Cloud Computing and Analytics Center. Some of the things that we currently have available through our center. Software as a service, business intelligence and data mining tools, things like Cognos, SPSS model. Those software things cost literally hundreds of thousands of dollars to purchase those. It's available through our center, through the cloud. Some platforms as a service, System Z development environment, course management systems, Sakai, social networking. This is a new thing that actually came out of Sakai Foundation called Open Academic Environment, and also infrastructure, Linux servers, ZOS systems. Okay. Am I out of time?
No, you're good. Do you have more, or can you take questions at this point, or what would you like to say?
I just want to quickly,
no,
5 minutes.
5 minutes?
5 minutes, all right. Give me 5 minutes, all right, good. So I'm going to explain every single dot on here. So again, back to the center. This is really the structure of our center. These are our partners. We're part of the HPC2, the High Performance Computing Consortium. So, cloud computing, really, we talked about what the benefits are. One of the things that we will be doing is working with IT companies and having those companies actually provide services to SMBs. It's not simply going to be Marist College that is going to be the provider. In terms of manufacturing, we don't want to be the IT company that sort of is working on providing those services to manufacturers throughout New York State. We would like somebody else to sort of be that person. We will certainly provide the infrastructure. We will certainly provide the expertise in terms of getting that implemented and so forth. But we want some other organization to sort of be the leads in terms of meeting with the various manufacturing, deciding who's going to be that IT company that's going to provide services to manufacturers throughout New York State. Our center is really made up of 4 components. The Cloud Computing Incubation Center. We actually have incubation space at Marist College. We actually have our first tenant who moved in there at the beginning of January. We have the small, medium-sized business cloud. We haven't put all the pieces together, but we want to be able to provide a cloud service to SMBs throughout New York State in terms of the delivery through the cloud of standard types of technologies that they'll be able to utilize. We have a Smarter Business Development Cloud, that's really related to analytics. And then we have Workforce Development Cloud. We also do training in these particular areas, 100% online, utilizing, of course, our cloud. The Incubation Center part, the S&B Cloud, Smart Business. The Smart Business one, I just want to talk about that a little bit. We have, as I said, some of the most sophisticated analytics tools, in the world. We're hoping to actually get the Watson Center, the Watson system, in our. So we've gotten Beyonce. She's available. I don't know what happened. How did we go to Beyonce?
We told you 5 minutes.
When your 5 minutes are up. This is like the what? Okay, let's go.
That woke everybody up.
That's not even on the screen over there. So, I was just going to say the exact same thing. What's very important in the cloud is security. You do not want things like this happening.
That's a different cloud, Roger.
So do you want to talk about hacking? Maybe we can talk about that. Yeah.
So anyway, I'm going to and my little dance that I like to do. So one of the things that we're doing, and we've already started conversations, is putting together the New York State Manufacturing Cloud. And the New York State Manufacturing Cloud is going to make available to manufacturers throughout New York State a suite of software, which will include CAD software, ERP systems, inventory type systems. But we at Marist don't know exactly what those should be. We have no manufacturing education being done at Marist College, so we need help, and so we're working with people to do that. We've already had a couple of meetings. So I'm going to end. Any questions?
Yes.
Beyonce?
Software as a service. Can we get a copy of the presentation?
Sure.
You have a lot of stuff that we go over.
Right.
Well, if it's okay with Roger, we'll make it available on our website.
Sure.
And then send everybody.
Absolutely.
I think of Microsoft, the model seems to be, we'll come out with the software and market test it on the public, and and as hackers crack into it, then we'll fix it. That seems to be the way they do things, and then they send out fixes. That's why one of the reasons I tend not to trust cloud computing.
I was going to say, are you asking, is that our model at Marist?
Well, how do you know what their model is? How proactive are these models that they're hack-proof? It seems really that hackers are always one step ahead of the companies that provide the software.
Yeah, and that is indeed a concern, but the infrastructure that we have in our research lab at the college that will support this is not a Microsoft-based platform. Our platform, we have one of the the largest Z enterprise systems available out there. There's something called Z Enterprise System, or something called the ZBX. It is one of the most secure, reliable systems out there. I'm not certain whether the answer is it has never been hacked, but it has very rarely been hacked. Its uptime is almost 100%. I mentioned that IBM is contributing $11 million a year to this particular project that we're doing, and they're our partners on this, and they're certainly to them this is going to have an IBM connection to it, and so we will certainly be working with them, making certain that this system is secure, reliable,
I also say this because as a person who's not only once but 3 times has had his credit card number hacked, not through my own computer, but nationally somewhere in some cloud computer out there, where thousands of dollars was drained out of my credit card. I didn't pay for it, thank goodness, because I had nothing to do with it, but it was one heck of a mess. And you'd think these credit card companies would be the most sophisticated of all of protecting data. They ain't.
If you give me your credit card, I'll make something.
Question? Sure.
Yes, 2 questions. One, when do you expect something like CAD to be available? You know, what kind of time frame do you think we're talking? That'd be question number 1. And 2, are there any local companies? Are there any companies already that if you wanted to become proactive as a business to take advantage of what's available in cloud computing, you know, where does somebody turn?
In terms of the CAD, I think that's probably one of the very first things that we will be tackling, because you know, we see it as something very doable. We also have been talking with some CAD companies in terms of what it is that we're interested in doing, and we also know it's something that manufacturers across New York State are interested in. And we also know that the governor is interested in manufacturing in terms of the state. And so we're certainly being viewed at by the New York State government in terms of what it is we're doing. So that is, manufacturing is one of the areas that I think that we're going to tackle very quickly. And I would say by summer time frame.
Really?
In terms of CAD.
Can I
That's
address this?
wait, there was a second part of the question. Oh, in terms of where do you go if you're a small business? One of the things that is part of our funding is marketing, and so me being here is actually part of our marketing. So I'm here telling people about what it is that we're doing at Marist College. But I have a person who works for me. Her name is Susan Scanlon, and she is my director of corporate outreach. She is the person who is the initial contact with the company if the company is interested in doing something with us. Initial conversation goes on with her. The company is then invited into Marist College. They will meet with not only her, but they'll also meet with some people from our particular team, which consists of faculty, consists of people from IT. We then look at the particular project that the person is interested in, kind of scope it out, look at it in terms of costs, look at it in terms of technology, look at it in terms of expertise. Do we have the technology? Do we have the expertise? And then come up with a proposal in terms of a work plan.
So, Roger, I just want to build on that for a second, because the whole point of CGAM is to try to bring these resources.
Some water. Go ahead.
To try to bring these resources together in now the 2 regions, Hudson Valley and Mohawk Valley, and also the North Country. Clarkson has joined us as well. And what we're trying to get together is a team of people who have expertise in these various areas, who would actually work with the Marist group to bring those resources with expertise, with help to you. So I think you probably can't service everybody in the state, and that's why we formed CGAM, is to actually bring some more resources to people.
Right.
Does that make sense to you?
Yes, and CGAM, remember I said that we don't always want to be that, there's the SMBs, and then there's, a company, an IT company or some sort of a company, and then there's sort of Marist College, below. We would always prefer that there's somebody in between us and the companies. And with respect to manufacturing, CGAM is a very logical choice. Now the thing is that, as part of our mission with our funding is we're supposed to certainly be delivering something to the Hudson Valley, because that's our region, but we're also supposed to be delivering things to the entire state. And so we would like whatever we do to become a statewide type of initiative, where we just get more impact from that. I'm going to take
real quick, how critical is network infrastructure to this?
Yeah.
I mean, is the internet fast enough and reliable enough for a lot of these initiatives, or do you see the growing dependence on private network connectivity, and that's cost too?
It all depends. It's always the best answer. It all depends. Think of CAD, for instance. If you're thinking about CAD software, by the way, is extremely sophisticated. Utilizes lots of processing capabilities. But the thing is that if you look at our analytics cloud that we have, it also utilizes some extremely sophisticated equipment that utilizes a huge amount of power. This thing called Cognos has these very sophisticated graphics, but we have people from around the country who access that at Marist College. But the only thing that they're actually sending across the network is really screen images. All the processing is being done at Marist College. Bandwidth in the situation where everything is sort of being done at the cloud site and all that's being exchanged is images, the bandwidth that most everybody has in their home is going to be enough. But if you remember that particular example I gave where maybe somebody is utilizing our analytics software, they don't want the data to be at Marist College. They want that data to be at their site. Well, then in terms of all that processing capability, then that data is also having to go back and forth and back and forth. And so then in that particular example, the bandwidth needs is going to be much higher. But more than likely, if you're working with a company that has large amounts of data that they're very, very insecure about putting someplace else, they're probably somebody that has high enough bandwidth.
Another question, Paul? Do you have a question?
Yeah, my question is basically, do you have a business card or something for your marketing person?
Well,
there's people here I think that would want it.
I've been at Marist College for 32 years. 22 of those years I was a faculty member. Faculty members don't carry cards. I've been the dean for 12 years. I still haven't gotten used to carrying cards, although I should be giving cards to people. Sometimes I remember, I just went to the Middle East. I came back from the Middle East. And before I went, we had this meeting. All right, everybody bring loads of business cards. Oh yes, I put them out on my desk. I went to the Middle East. They're still on my desk.
Well, we'll get that contact information on the website.
Yeah.
Get you all links to it, so
good.
Everything will be there.
Yeah, if you actually just simply come to if you go to idcp.org, which is the Institute for Data Center Professionals, Susan Scanlon will come right up. But she's your first line of contact.
I'm from a local company, and we're a communications company, and one of our products is cloud services. Do you see us as a partner potential,
Absolutely.
or do you see us as a competitor?
No. You're a partner. My picture's not up there. But if you look down, in terms of our partners, some of our partners are actually data centers, in the Hudson Valley. We have a data center, down in Rockland County. That's one of our partners. When any particular project starts, it's all going to take place at Marist College. It's going to be our initial test environment. And but if you think of the CAD software or the manufacturing cloud, maybe for the first 2 years it's going to be at Marist College, but then it's going to grow. We do not want that. We cannot support that at Marist College. We're also in applied research. We're a university. We're not a company. So we have partners that we will then take what we've done, and then we will lift, shift, and drop into their environments. And so, no, you would not be our competitor. And if you were interested, for instance, in perhaps working with Marist on putting together some particular, cloud service that, maybe you don't have the, the resources, the technology infrastructure, and you want to, play with something, you could come play with us. And once we go through, well, she's not there all the time.
Hey, any other final questions for Roger? Okay, well, thank you, Roger. I really appreciate your presentation this morning. And now we're going to move, and I'll to Chris Urban. Those at SUNYIT, of course, know Chris. Chris is one of our instructors in our computer science area. And I'll go ahead and pull up your presentation.
Thanks very much, Mark. As Marv said, I am a faculty member here at SUNYIT. I've been here for 13 years. I grew up in this area, left for 20 years, and spent some time in the United States Navy. Half of that time I was flying planes off of ships, and the other half of the time I was doing things computing and education. I was a CIO for a while at the Naval War College and Wargaming Center. I taught at the Naval Academy, and it's great to be back at home for the last 13 years. I probably don't need that. All right, so let's.
But do you know Beyonce?
I do not know Beyonce, unfortunately. I wish I did. It would make me a lot more popular. We're going to talk about a variety of things, and it's always difficult to follow a great speaker, and it's always difficult to anticipate what that speaker is going to say and try to say things that are complimentary to him. So let's just talk a little bit about history quickly, and to give you some perspective. When we talk about digital technology, we talk about computing and networking, things that we do every day, we need to understand that this is a new thing, all right? And it's less than 80 years old. John Atanasoff, who was a was born here in Hamilton, New York, is actually the person credited with developing the concept of the digital computing machine. He did it with a partner named Clifford Berry at the University of Idaho in the late 1930s, and he is the person who put together all the parts that are essentially what we do today, all right? And it was not accepted. Computing, as you remember, or you may not remember because most of you are not old enough, but computing was not really thought of as being anything truly useful. All right, as a matter of fact, Tom Watson, who was the president of IBM in 1943, said, hey, this computing thing, pretty cool, but we only need probably 5 of them in the entire world. All right, there's really no market for this thing. Well, in the mid-50s, businesses started to figure out that, there's some real power here. There's some things that we can do. And there's ways that we can utilize and leverage this computing technology into things that are very powerful and that make us much more efficient. All right, we can do lots of things that we do already. We're not going to do new things necessarily. We're going to do them much more efficiently, and we can get a lot of economies of scale there. And businesses started taking off and really employing computing technology. It wasn't until the 70s that businesses started using computing technology in a different way. Instead of doing the things they always did before, no disruption, as Roger said, it was the same things. In the 70s, we found that, hey, this computing technology stuff is really cool in a different way. Because now we can use it to do things we never ever did before, things that we never thought of doing before. We can search for hidden patterns, we can mine data, we can come up with modeling techniques that allow us, in my own field, I was an aviator, that would allow us to figure out where the danger areas are, so that instead of sending pilots out to crash, as we did in the 50s, now we send them out and confirm what the performance of the airplane is going to be like. All right, and I was at a conference a few years ago, and one of the chief test pilots at Northrop Grumman was doing overlays, and he said, here's where we thought the modeling was going to put the airplane, and here's what we actually confirmed. And they started doing overlays, and they're almost superimposed on each other. That's an amazingly powerful thing. That's being able to do things you couldn't do before, and really harness that technology in a unique way. Personal computer sales didn't start until the 70s. Right? And there's some discussion about that. You can find onesies and twosies, big personal computers back in the 60s, but really they didn't start until the 70s. And before 1981, or by 1981, about 1 million PCs were sold, personal computers. IBM released the PC itself, all right, its PC, in 1981. And in the next 4 years, they sold 5 million of them, all right? In 1990, over 20 million PCs were sold. It was also interesting that in 1990, Windows 3.0 came out. Windows for Workgroups, first good version of Windows, really allowed you to do some cool stuff. All right, and also in 1991, the World Wide Web was made publicly available. Mosaic in 93, all right, now 2013 today, Mosaic in 93, all right, 20 years ago, there's no World Wide Web, we just introduced the concept of browsers. Look what happens. By 2000, you got 140 million computers sold, personal computers. Huge boom, because this thing is useful. It is cool. We can access things. We can point and click. It makes that technology accessible to the average user. all right, in a very easy way. By 2008, we sold 1 billion computers, and it's projected that by next year, we're up to 2 billion personal computers sold. So computing is here to stay. It's going to continue to get greater and greater as we move forward in history. All right, cell phones, you know, even a faster story. There are today 6 billion cell phone subscribers. All right, there's only 7 billion people in the world today. 75% of the world's population has access to a cell phone. That's an amazingly powerful thing. When you think of the fact that our cell phones today are really not phones. All right, they are devices that allow us to communicate not only by voice and by text. But smartphones are essentially small computers. All right, they allow us that graphical interface. They allow us to access the web. They allow us to do things, to run applications from our device, wherever that device is. All right. Metcalfe's law. Bob Metcalfe, one of the pioneers of computing, is Mr. Ethernet. If you've ever used Ethernet, you're using the work of Bob Metcalfe. He developed this notion of Metcalfe's law that says the value of telecommunications network is proportional to the square of its connected users to the system. Early on, when there were a very small number of users, the utility of networking was not readily apparent. As we get more and more users, the utility of networking becomes super apparent. All right, nobody discusses anymore. Hey, is this a good thing? It's obviously a good thing. We can quantify it in a very real way. So networking and connectivity, tremendous stuff. Tom Friedman, about 8 years ago, wrote "The World is Flat," proving that the world, whether I'm here, if I'm at this machine, and I'm connected to somebody either by voice and video or by text, however I'm connected to another person on that machine, whether they're in the room next door or in New Zealand, it really doesn't matter. All right, we're here connecting, sharing things, working in real time. E-commerce started right after the World Wide Web and browsers. All right, entrepreneurs saw opportunities. Yahoo was in the market on Amazon in 1994, eBay in 95 along with Google. By 1997, everybody was a player. Every government, every major business, many small businesses even had a web presence. Things moved rather rapidly. And again, we're talking about just 15 years ago. So when I say 1994, that's less than 2 decades ago, we've got e-commerce really coming online, and now we're moving forward. Cloud computing, you know, the first reference to that was in 1997. The first cloud computing company was probably 1999, it was Salesforce. Salesforce looking at the opportunity again to say, if we have a browser and we have such great connectivity that we can get people from a browser to anywhere else, maybe we can do business in that way. In 2002, Amazon developed a business model, and this is really important. Amazon developed a business model to make use of its own necessary excess capacity to allow other people to use Amazon's resources. So you could actually, Amazon EC2 was their attempt to say, you know what, I have all this excess capacity to be able to handle peaks in the market. If I make that excess capacity available to somebody else because I don't use it most of the time, maybe I can actually reap benefits from that. And maybe too, this is a win-win situation where the people that are actually using that Amazon excess capacity are able to do things they couldn't do before at a price point that they couldn't do before either. So today we see explosive, you know, from 2002 to today, explosive growth in cloud computing, and we're talking about services provided to anyone, anywhere, at any time. What are the driving forces here? 3 really. You know, this pervasive and mobile computing. No matter where you go, you take your office with you. No matter where you go, you can be productive. Marv was telling me the other day he was stuck in traffic. The weather was bad a few days ago. Route 49 was closed. He had an accident. And Marv was sitting in traffic and whips out his smartphone and is able to do real work in real time sitting in dead stop traffic. And he was totally productive.
For an hour and a half.
For an hour and a half. I'm borrowing this term, the next term from Bob Metcalfe again, squanderably abundant bandwidth. All right, it is available, it's out there, there is tons of it. All right, how do we know that? Roger told us that 30% of the traffic at night is Netflix. I would say that's squanderably abundant, okay? We're not doing anything really important with Netflix, although I love watching it too, I have an account. All right, but you know, there is bandwidth available, and that bandwidth is only going to get greater. The great thing about the .com you know, bubble, you know, the 90s, is that it triggered, you know, this ridiculous $2 billion investment in fiber optic cable. All right, That is the gift that keeps on giving, okay? When you put that cable in the ground, all you do is light more and more capacity at the ends, improve the switches, change the transmission technology, and you're getting greater and greater bandwidth, all right? So it's out there. And the proliferation of internet services, as we become this more connected society, you can see we are 2 billion PCs, 6 billion telephones, many of those telephones, smartphones, people are using them in this way. There is just a tremendous amount of internet services available, like Google, like Amazon, like Facebook, which we all use. Everyone here has probably used those services. I built this presentation because I was hoping that you might want it, but I also embedded a lot of links to this presentation. So if things that are myths about cloud computing, all right, and we're gonna, the reason I built in some of these links is so that you can walk away and actually use them in a real way. All right, let's move over just a little bit.
There's kind of a quality presentation when you think of it.
All right, small businesses already, myth number one, small business owners already know when they're using cloud. Many of them don't. All right, many small businesses utilize things like Gmail, Facebook. Our first foray at SUNY IT into cloud computing in a major way was email. All right, we had a few years ago, we had a solution on campus for email that was, involved servers that were on site here that had a dedicated person administering those services. It involved software that we paid for, and the product was not really that good. All right, there was a lot of dissatisfaction. We got students in the crowd, and when we started doing it, I was really involved with moving from the system that we had to a different system. And one of the major metrics that I was using was customer satisfaction. If you read my bio, I'm a big believer in life is very simple. You can measure things very simply. If you say happiness equals reality minus expectations. If your expectations exceed reality, you have negative happiness or unhappiness. You can do one of two things. You could lower your expectations. That might have to happen. But you can also increase reality, okay? Or if you increase reality to exceed expectations, normally that changes the result of that equation. So our students, when we started looking around, we said, hey, how happy are we with email? They voted with their feet. Our students universally didn't use our email. They used somebody else's email. They used Yahoo, they used Google, they used Hotmail. So that made us move towards, Gmail. And think of this as a solution for us, Gmail for us. And this is not the same thing because, again, we're an educational institution. We get Gmail for free, but it's hard to beat free, as a business model. We got rid of our servers. We didn't have to have servers or storage devices. We didn't get rid of our technician. What we did was we repurposed that technician to do something important. All right, something that we couldn't buy elsewhere. All right, so that was an important thing for us. So small businesses already are in the cloud. All right, cloud computing is expensive. That's not true. You pay by the drink, as Roger said. You pay for the services that you want. You pay as little or as much as you think you need. It is very tailorable. It's very scalable. There are lots of services available, and it depends on what you're interested in to how much it's going to cost. Additionally, you want to cost this thing out and figure out the present value, the net present value of your system as opposed to going to the cloud. If you're paying for servers, if you're paying for technical services, if you're paying for all that infrastructure, and there's a possibility of doing it better on the cloud and for a lower cost over a period of time, that may be very interesting to you. All right, cloud services reduce productivity is another myth. That probably is not true. All the indications, all the research we've seen indicates that productivity goes up. All right, and using personal devices in a business environment is safe. When leveraging cloud services, that's bad. That's a bad thing. We know that most of the data breaches are caused by personal computing devices. So there's some issues there. There's some things there to look at and to play with. All right. Now, again, simple approach. What is this thing, cloud computing? It really is a layered approach. If you want to think about the cloud, it's in layers. All right. We like networking because of layers, like the OSI model, the TCP/IP model. We also have a layered approach to cloud computing. And at the very base level is the real hardware, the servers, the storage, the networking, the cabling, the cooling, the power, that stuff, all right, things that are really tangible, all right, that we can break, that we can move. The next level up is software, all right, operating systems, virtualization, those kinds of things. Above that, the ability to do testing, development, quality assurance things. And then above, on top of that, ready to use tailorable applications, all right, that application layer. Well, if you want to think of that layered approach and try to, get some feeling for, infrastructure, platform, and service, all right, infrastructure as a service, platform as a service, and software as a service, this is what infrastructure as a service is. You buy these things. You buy the ability to use somebody else's storage, networking, operating systems, and virtualization, whether it's Amazon EC2 or Rackspace or the Google Compute Engine. If you want to move up and say, okay, and this allows you again to do the testing and development, the quality assurance, the stuff on the top. So this is the cloud, and this is you. All right, you're deciding in this place to use somebody else's infrastructure. You can move up a level and say, okay, not only going to use your infrastructure, but I'm going to use your testing and development environment. All right, something like Windows Azure or Google App Engine is an example of that. Develop your own apps, but you have to use Azure or Google App Engine to do that. All right, so you're going to develop your own services there, and then finally, the top layer, you go for the full Monte, if you will. All right, everything, and you want to do software as a service. So things like Dropbox, Salesforce, QuickBooks, Office Time, all those things. Essentially, all you need to do is have a browser, and you can pay for those services. You can connect to them without ever talking to a human. You can purchase them with your credit card. I thought that your graphic there of what cloud computing is not is absolutely true. You shouldn't talk to anybody. It shouldn't cost you. You should be able to use a credit card. You should not have anything that you own. It should be very flexible and tailorable. So it's a great starting point. I think for most small businesses, my interest is leveraging information systems and computing technology to solve people's problems, to make business people more productive, more efficient, and effective. My own personal metric again is, why would I buy anything or why would I build something if I can buy it at a lower cost? Okay, if I can buy it at a lower cost and it meets the quality, my quality expectations, and certainly my delivery time is going to be quicker. Okay, I'm certainly not going to have to build something. I'm not going to have to buy hardware. I'm not going to do cabling. I'm not going to do all that stuff. I can actually go online. If I'm talking about software as a service, the highest level, which for I think most small businesses is a great entry point, especially for very small businesses. Why would I not think about doing these things? Okay, there is enabling software. Right? So when you work with the cloud and you're talking about software as a service, you have software available that allows you to do on-demand access and service. Again, you need the browser. The browser is your entry point into this. You do self-provisioning, which means that you don't have to interact with the salesperson. You can actually buy this thing and pay for it and use it and configure it without ever interacting with the person. So that's what self-provisioning is about. Metering, it's all done in an automated way. It's elastic. If you need more of it or less of it, you can meter it up, or not only meter it, but you can expand it or contract it as you see fit. Amazon EC2, I think that the last time I priced it out, you can buy a virtual server, a single virtual server with 8 gigs of RAM and a couple hundred gigs of memory for $40 a month. However, if you want to, you can buy 100 of them for an hour for $40. I mean, so if you need to expand, there is a great ability to do a lot of interesting things. And multi-tenancy is essentially means that it's the same application that other people are sharing, and there's economies of scale there. So if you're working in Salesforce, if you're using Salesforce, software and applications, so are 100,000 other companies, and you're using the same applications, just spreading that cost across a wide spectrum of users. The cloud can be public, private, or a hybrid of both. All right, large companies, not small ones. I would imagine most large companies are either private, have private clouds inside the organization, kind of the equivalent of an intranet, if you want to think of that, an analogy there. Some large companies and small companies do a hybrid. They want their data locally. They want to protect it. That data is the most important thing, and they use applications from outside. I would think that in many cases, small companies would be most interested, very small companies, in doing the public cloud, where everything is outside of the organization. Again, because that minimizes your IT footprint. Right? It minimizes the hardware and the software that you have to buy. I'm not going to go through every one of these, all right, but I've got links. All right, I've got links. These are reviews by PC Magazine. PC Magazine does a great job. All right, and I've got a number of here. I think I've probably got 20 of them. And these are all different forms of cloud services that are available to you. So I'll go to one if you're, just to give you a flavor of it. So you go to, looks good, let's get the ad. All right, so office time, and you get the, you got to put the advertising, but it's how much it costs. This is what it does. It does billable hours and generates invoices and reports. It gives you very long reviews. It gives you also comparable similar products. So I've got, I think, 20 of these things, and this is just a place for you to start. I mean, these are cloud computing services that are reviewed well. Things like Sage 1, Adobe Forms Central, DocuSign. If you need to do signatures in the cloud, you can do that. Office 365, Adobe Connect, Gliffy, MindMo is a great brainstorming software. Do mind mapping. Salesforce, very well known. 1999, really the first commercial company in the cloud computing arena for sales. QuickBase, Box, FreshBooks, Intuit Online, Microsoft SkyDrive. Last one, not many people know about Lynda. And Lynda is a training tool. All right, so if you need to keep your technical services sharp, you can buy that capability by using Lynda Online, and you can use it for either yourself or folks in your company. Who should be driving the cloud train? All right, I'm a big believer that it should be not just the IT folks and not just the CEOs, but it has to be a joint effort, because this is really not only about technology, as Roger has alluded to. It's not just technology we're talking about, it's a business proposition. How are we going to do our business? We're going to do our business differently by employing the cloud. And how we employ that, how we employ the cloud, what we do, what kind of complementarities and power that we're looking to gain from the cloud, the access, all those things are things that are the core nature of the companies that you're in. You need to decide that this is a smart thing for you to do, not just because it's cool, not just because it's high tech, but it's got to be a smart thing for you to do and to move forward on. And those are the kinds of discussions to have with the IT folks. It's not a panacea, all right? You need to go out there, and what I don't want you to walk away with today is to think that, hey, in every case without fail, cloud computing is the solution, okay? There is no ubiquitous good in the world, all right? It is a thing that is important. I think it's going to grow. It is very interesting for a lot of reasons that we've discussed today. But you need to go in with your eyes open, and you need to do your due diligence, okay? You need to ask hard questions. You need to cost things out to make sure that that this is something you want to investigate. So this is a great basic checklist. All right, I'm going to shift it down here. Maybe too small. All right, so you want to ask yourself questions about availability. What are people going to provide you? What are they going to guarantee? What kind of services are there? Data storage. Is it going to be encrypted? Is it encrypted, and what kind of encryption is used? What kind of access do you have? What kind of downtime do they have? How often are backups scheduled? Do they use RAID? How scalable is this thing? I mean, in a perfect world, it's instantly scalable, but I can tell you from conversations with some companies that, 2, 3, 4 hours is the scale time. So if you need some faster reaction than that, you need to know that going in. You have to ask those questions. You don't want to be surprised. What happens if you want to terminate? Can you back out? All right, you should be able to. There may be a penalty. What is that penalty? Can they terminate you? What kind of support are you looking for? All right, so these are all questions that you need to ask to make sure that you're getting into a situation that is right for you. All right? Less than half an hour. All right?
Not bad.
All right. Had to go fast. Didn't want to keep people over time. Yes?
Is this online too? So
I will make it available. I built it so that Marv would have it, and if anybody contacts either Marv or me at SUNYIT, I'll be happy to share it.
And again, everything will be on the website, and I'll send you links. Provided I have your email address, I think
I built it just so you could have it.
All right.
What else?
What effect do you think Google Fiber is going to have?
The two cities, it's an amazingly cool thing. Students and I were talking about that this week in one of my classes. You know, the two Kansas cities, you know, imagine if you will, and I was one of the main folks behind our county's submission for Google Fiber project. And you just think of all the amazing things that you can do. Having, what did we say, it was five down, one up? I think 5 megabytes down, 1 megabyte up.
Guaranteed free for 7 years.
Yeah, guaranteed free for 7 years. How amazing and cool is that? So think about the things that you can do with that kind of bandwidth. The ability, I mean, at every spectrum. Imagine people who are shut in that need access to healthcare, that need translators. You know, we have 63 languages that are spoken here. Imagine the ability, because you have, you know, that kind of bandwidth, you can do high definition connectivity right to somebody's home and have the telemetry involved with the real-time voice and video at such high quality that you can do real diagnoses there. I mean, there's a business out there to be spawned. You know, the ability to do all kinds of connections and form all kinds of new things and share information like never before. I think that, you know, it's not unthinkable to say that 30 years from now, maybe the two Kansas cities are the norm. Okay, you know, that is where, you know, the demand for bandwidth. We know that as we build bandwidth, people light it up. As we build bandwidth, people use it. It's kind of like memory. You know, I remember lying to my wife, not intentionally, in 1987 when I bought my first PC clone. And I told my wife, if you let me spend this $250 extra for the 20 megabyte hard drive, it's all the storage I'll ever need. You know, I mean, well, now I have you know, a thumb drive here that I paid, I think, $20 for. It's a 32 gigabyte, you know, thumb drive. You know, that I can wash. Because I've done this, I put them through the wash, and I just let them dry out, and it's perfect. It's wonderful. You know? So the technology is just getting better and better. So fiber, I think we're going to see more and more of that.
I just want to follow up on your comment that I agree with you. I'm from Northland, and we are building fiber in the community here. We're into almost 400 buildings now. We're building into business buildings and not residential at this point. But you're right about the bandwidth. We have customers with speeds of 10 gig. We have customers who we've provided dark fiber to. But our typical customer, we are experiencing almost 60% of them are upgrading their bandwidth speed. And they're not just adding 10 or 20%. They're doubling and tripling it and beyond that. It is just that we knew we needed to build the fiber, but we never anticipated the kind of explosion that is out there that we're seeing in bandwidth just by putting the fiber in the buildings.
It is amazing that people who make the leap and go from you know, a fiber optic network to you know, they've been using DSL and they think that's pretty good, and folks like me who are very comfortable with my students that don't remember or have never used a 56K modem. You know, so you know, my first modem was a 300 baud modem. You know, a Hayes modem, 300 baud. You know, and I watched the characters come across the screen. You know, and
you thought it was great.
I thought it was great. Exactly right. It was worth the $300 I paid for it. You know, you know, we are as technology gets better. You know, there are just more and more folks that are finding ways to use it. You know, in new and innovative fashions. And it's just going to continue. The creativity of the engine of us is just going to get greater and greater. So they're going to soak up that bandwidth like nobody's business.
It's going fast. It's amazing.
What's dark fiber?
Just your own fiber with no electronics on. You can put your own electronics on the end as fast as you want to go. We just put the fiber there, so there's no limit to the speed. Whatever you want to put on. Whatever switching you put on the end.
I was wondering if either one of you heard what Cornell's going to do. Gates, all their building is unique.
I don't know.
I don't know.
I can't answer that.
I was down at Stony Brook last summer and saw some amazing holographic work done with huge bandwidth, you know, from multiple locations. Kind of almost, you know, I hate to say Star Trek holographic deckish. But that kind of thing, you know, with amazing bandwidth from other places in real time. So you're experiencing, you know, being immersed in, you know, this room as a demonstration, but getting all the images from, you know, across the country as you're part of it. And the quality was just incredible,
Unlimited bandwidth scares me, though. Unlimited bandwidth, because the fact if you think of, you know, I have the infrastructure, you know, at one end of that bandwidth. And so I know I can share that infrastructure with lots of people because, you know, there is limitations in terms terms of the bandwidth, in terms of getting information across and so forth. But you know, when you get to the point where everybody sort of has this, you know, wide pipe, that then increases the amount of utilization that's going to be needed on this end. And instead of being able to share something across 100 people, bandwidth goes up, they're expecting things much quicker, you know, then goes down to 10 and so forth. Obviously, I want bandwidth to go up, but it creates some challenges on the other end of that bandwidth.
You know, think about all the amazing business models that are out there. That you know, we're limited right now. You know, I think something that everybody understands is cable TV. We talked about, you know, we're talking about cable TV in class this week. You know, we're limited. You know, I have 200 channels that I don't watch. You know, essentially because I have to buy that service in order to get, you know, the channels I do want to watch. I probably never ever watch 150 of my 200 channels. But with incredible amounts of bandwidth, who's to say that the providers of that content don't go direct in a business model that cuts out all the middle folks, all right? So you know, we see this now with the NFL. The NFL is going direct in many ways, and maybe they continue to go direct. And they cut out the networks because because they have access that they didn't need to pay for through the networks anymore. The distribution packages that made sense in business models previously no longer make sense because everybody has access to this squanderably abundant bandwidth. And we start seeing, you know, new spin-offs in business models, which changes how, you know, folks like networks are going to do things. How are they going to change their business models to adapt? Some of them won't. Some of them are going to go out of business, and we know that. We've seen that happen. I mean, everybody who's been, most of the older folks in the room heard of Wang Computers. Wang Computer in the 80s was one of the most successful computer companies on the planet. It was out of business in the 90s because they couldn't adapt. IBM is still in business today and almost making no PCs. All right, they make no PCs and essentially very little software. They're in the mainframe business. They're doing experimentation. They're doing development. They're doing a lot of cool things. They have adapted and continue to adapt and been very successful. So those business models, you know, the use of technology to make the business models make sense, or taking advantage of the technology to come up with these business models that allow you to be successful is really, really important.
Where are we at with risk as we continue to depend more and more on central, the hub, spoke kind of deal. Everything's focusing. And then we see in the last couple of days the federal government admitting that there is problems, say, with China. Where are we at with the risk? Who's studying the risk to determine our security? We're
looking hard at that. I mean, that is a huge area of research, and we're doing a lot of encryption. Now the cloud, and one of the things that makes the cloud interesting is that the resources themselves are dispersed. I mean, they're not in a centralized way. So don't think of the cloud as essentially the old, you know, mainframe and dumb terminal thing, you know, because that's not the case. You're not locating all of your stuff, you know, the applications and your data on one box. You know, they're, you know, replicated, recreated, and normally we would think that from some point of view, the cloud has a failover capability to a much greater degree than many organizations because of the replication of the applications and the data across the multiple sites in the cloud. But there's a lot of research here. We don't understand well how to talk cloud to cloud, for example, how to move things from cloud to cloud. The addressing schemes aren't there that we understand. IPv6 will make some of these things very, very interesting and very, very powerful for us, but you know, there's a lot going on. The security is going to be, again, you know, is paramount. We have gotten better, if you've noticed, we've gotten better at doing security, I think, in the IT industry. Many of our security breaches are shooting ourselves in the foot. I mean, doing stupid things. You know, not being secure with our own personal devices. You know, the bring your own device thing is a very big problem. You know, if we can limit, you know, the ability of our users to use our devices, that makes a lot more sense. But then it defeats the notion of mobility. You know, so we want to be able to access our businesses and our tools from everywhere. So,
in answer to your question, the U.S. military is going to add 4,000 people. Right?
It's happening right up at the business park right now with a new company.
And while we're on the subject of cybersecurity, I'd like to ask John Marsh to talk about a program that we're doing here at SUNYIT.
John is the chair of the computer science department here at SUNYIT. He's my boss. So.
Well, just as a point of information, we are participating in this whole information security arena. We have a bachelor's program which is just finishing out its third year. It's a 4-year bachelor's program in cybersecurity. And really the announcement for today, or this recently, is that we've gotten state approval to offer a master's degree program in cybersecurity also. It's called Network and Computer Security is what we call it, and it's aimed at professionals in the field, not only who are out there securing business systems, that is the infrastructure to put a business online, switches and routers, but it's also aimed at those who are out in Rome, out at the lab, and doing cybersecurity research. So that's just a point of information. This is a new program that's starting up in the fall.
And one of the things that is not unintentional is the advertising for this. Notice that it's a lock in the cloud. Right. So.
Right. This is really the forefront of security research and practice, is trying to figure out how to secure the cloud.
Yeah.
Okay, any other questions for Chris? Yes, sure.
Do you have any services that you recommend if you wanted to start small, like, just doing standard backups for your business? Are there good ones out there?
Yeah, absolutely. There are the ones that you hear about, that advertise, Carbonite and Rebit. I mean, there are those services, and they're out there, and by and large, they're very well rated and they're very successful. So I think that that any of those that you look at, I mean, go for the best price point for you. They all have differences in how they work, but you want to compare them together. It's easy to, if you go to my links here earlier at Rebit or Box, either one, Rebit Pro or Box, you can go there, and they list alternatives also in pricing schemes and reviews. And PC Magazine is a pretty honest broker. They don't. They're really not interested in hawking anybody. They're not a Microsoft, mouthpiece or anything like that. Not that anybody is, but they're pretty well respected in their reviews. So that's a good place to start.
Any other questions for Chris? All right, Chris. Well, we really appreciate it today.